This video we're going to be evaluating with negative exponents. So before I start going over some examples, let me go ahead and explain the definition. So we have base a to the negative n. So negative n is the exponent. Basically, that negative value on the exponent, it's telling you that a is in the wrong place. What do I mean by the wrong place? Well, let's remember that whenever we have any variable or any number, it's kind of like having it over 1, right? There's an invisible denominator right there, which is 1, right? So by telling us that we have a negative exponent, it's saying that a is in the wrong place of the fraction. That means that a should not be in the numerator, it should be in the denominator. So this becomes 1 over a to the positive n power, right? Now a is in the right place and the exponent can be positive, right? Notice how the exponent was not brought down with the a, it just stayed there, but now everything is in parentheses, and then we'll have a 1 left in the numerator because we still need to have something left in the fraction, on the top part of the fraction. Now it can be that, and the other definition that they give to this is that if we have a over b to the negative n, again, this means that a and b are in the wrong places. A is in the numerator, it should be in the denominator. B is in the denominator, it should be in the numerator. So this will become b over a to the positive n. So now the exponent is positive, that means b and a are in the right place of the fraction. So now let's go ahead and solve and evaluate some examples. So for the first one, let's say we have 10. Let's say we have 10 to the negative. Oh, what's going on? So 10 to the negative 2. So we have a negative exponent. That means that 10 is in the wrong place. So this will become 1 over 10 to the second power. Right, now 2 is positive. Now by the power rule, we can say that this becomes 1 to the second power over 10 to the second power. So again, the 2 is going to be affecting both, right? The numerator and denominator. 1 to the second power is 1, and 10 to the second power is 100. So this is 1 over 100. Let's go over another example. We have 1 over 4 to the negative 2 again. So again, this negative is telling us that the 1 and the 4 are in the wrong place. So we're going to have 4. I don't know why is it doing that. Let me check again. So 4 over 1 to the positive 2. Okay. Now this will be 4 to the second power, and then over 1 to the second power. This will be 16 over 1, which is 16. Okay. Let's try another one. We have 2 over 3, and then to the negative 3. So again, this negative exponent is telling us that 2 and 3 are in the wrong places, so we gotta flip them, right? So it will become 3 over 2, and now our exponent will be positive. So this means that we have 3 to the third power over 2 to the third power by the power rule of quotients. 3 to the third power will be 27 over 8. This will be our final answer. We cannot simplify it any further. And then let's try the last example. This is a little bit different. This one is negative 5 to the negative 3. So basically that negative 3, it's only affecting the 5 and not the negative. Remember, if we were to have parentheses, then negative will be affected by the exponent, but because we don't have any parentheses, it's only the number or the base under the exponent. So this will be negative, and then again we have kind of like a 1 under the 5, an invisible 1, because we have a negative exponent. We gotta move that 5 to the denominator, and this will become 1 over 5 to the third power. Now positive, so we will have negative, and then 1 to the third power over 5 to the third power, which equals negative 1 over 125. And that is our solution for example D.